Hello all, this is Meela Mitra with Space India, and I have with me here Vikrant Narang, uh, Educator Space, Senior Educator Space, and
Hello
Prabhu.
all, this is Meela Mitra with Space India, and I have with me here
Yeah,
Vikrant Narang, uh, Educator Space.
So, and I have here with us Prabhu from Chennai, and we are still waiting for the space team to send us the broadcast. Space team is right now based in Oregon, and they're still trying to get the connectivity. So meanwhile, while we're waiting for them, please bear with us. And we do have, there are other sites showing this right now, such as SLU and NASA. But we are going to try and get our own web stream soon from Sachin Bahmba, who's heading the team at Oregon. So meanwhile, I would like to ask Vikrant to share a little more about this eclipse and tell us why this is so unusual and why it's got the fancy of everybody in the world right now.
Yeah, yeah. I can't hear you, Mila. Thank you so much for the introduction, and thank you everyone for joining in. I hope my audio is loud and clear. So welcome to this Eclipse cast by Space. Today we have four team members from Space: Mr. Sachin Bahmba, Mr. Kannu, Mr. Surinder Solanki, and Mr. Love Sharma, who are at Oregon in USA and will be broadcasting this eclipse live from there. They are there to broadcast but also conduct scientific experiments, which include taking flash spectrum of the sun, and their imaging will include taking a beautiful diamond ring, Bailey's bead, solar corona, and which I'm going to show you in slides. So let me begin my slides here. So this is my presentation, Chasing Shadow of the Moon. So in many of us in India are afraid of eclipses. We think like eclipses have some sort of bad omen. I remember when I was like many years back, someone in my near my colony, when I was like very fascinated with the eclipses. So I used to hear people talk about how they were scared and they were like looking for to discuss with astrologers. So this is a presentation by Mr. Sachin Bahmba, which was used. So you can see space has been chasing eclipses. On the left of the screen, there is a beautiful diamond. You can see one of the pictures taken by space team during a solar eclipse expedition in Turkey in 2006.
Vikrant, have you shared the presentation?
Yes. Okay. Okay. I'm so sorry. I think I missed my screen share. Okay, I'm sharing my screen now. You should be able to see this? Okay. So Chasing Shadow of the Moon. This is a presentation which I'm using, which was prepared by Mr. Sachin Bahmba, the founder of Space, who is leading this team from space to the wonderful eclipse which is happening today. So on the left, you can see a beautiful diamond ring, and that's sun, and the black thing is over there is the moon, and on the right we can see a beautiful corona of the sun. I remember in 1995 when I saw the corona for the first time. It was in Madhya Pradesh, in Bhind, in a very small town, Bhind. So I was just about almost 9 or 10 years old, and it was one of the most beautiful sights I've ever seen. So that's solar corona. It's the atmosphere of our sun. That's space team in 2006 in Turkey. There's a beautiful ocean, and that's Mr. Sachin Bahmba right there in the center in the white T-shirt. Space team on his left over here is Mr. Surinder Solanki, and these are students who have been part of such expeditions. So they are enjoying the eclipse. It's like a festival. So this is just like they are observing an eclipse. You can see they are holding solar goggles. seen with solar goggles except when it becomes total. Now here are those photos again. You can see corona, which is slightly overexposed. So solar eclipses are of three types. One is total solar eclipse. That's when the moon completely hides the sun. Then there is annular. Annular means only a ring will be seen. So annular means a ring. So you can see in the middle photograph, there is annular solar eclipse. You can see partial. So today, for the team in Oregon, the partial solar eclipse has started, and totality for them will start in another 15 minutes. So I would like you to, if you have got a pen or paper, please note down the totality will be happening at 22:54. That means for 6 minutes to 11. That will be the best time to watch this eclipse. So this eclipse, there is a first contact. Then the partial solar eclipse begins. First contact has happened a few minutes back already. So the team was very excited when they just told us over phone that this eclipse has begun. Then you can see the second and the third contact. The total solar eclipse, that means the corona of the sun is visible. And then we see partial phase contact. So this will take almost 2 hours 40 minutes. Sequence. So this describes how this eclipse will progress today. It will start with a partial eclipse. That's the topmost row. And then we will see totality, but on either side of totality, there will be two diamond rings, one on each side of a partial solar eclipse. This one is from a previous eclipse. So I'm going to show you an animation. This is Earth as seen from space today. So we are seeing how eclipse, the shadow of the Earth, so shadow of the moon is going to America. You are seeing the cities which this eclipse will cross. So you can see this eclipse crosses the entire breadth of America. So people who will be falling behind that black dot or the central red line will see total solar eclipse. So that's where many millions of people right now in America will get to know about their reports tomorrow. Most of the America, including Canada and Mexico, will be seeing a partial eclipse. It's going on right now. So here is the same eclipse in a different, here's a different map. This central band is the band of totality. And right there where you see this part, is where we will see the maximum eclipse. The maximum eclipse, maximum duration of totality people are going to see for this eclipse is 2 minutes 40 seconds. And our team, we will be showing you 2 minutes, we will be showing you totality of 2 minutes 11 seconds. So what I want to tell you is, like, just before totality, when I was in Madhya Pradesh, I remember like things going, not real snakes, but appearance of shadow, dark and light bands, which will seem to rapidly cross the surface like a wall or ground. So these are shadow bands. This happens जैसे तारे twinkle करते हैं, जब हम कहते हैं तारे twinkle करते हैं. So imagine when the sun will be like a very thin, very thin line. Even sun will be kind of twinkling because of the atmosphere, and this effect causes us to see shadow bands on the ground. So it's a very beautiful phenomena. Another depiction. It's not a real image. This is one of the experiments space team is doing. On the left, we have the sun, and on the right, we will take its spectrum. So that orange color thing is the layer of the sun. That means it's about 2,000 kilometers thick layer of hydrogen. This is not photosphere. The part of the sun we see is the photosphere. So this is above the photosphere, a very thin layer. And on the right, we can see a spectrum of the sun. This tells us about what all elements are present in the sun. A few super cool photographs. So you can see solar corona by Milosev Druckmüller. He's a German astronomer. This is one of the photographs we are attempting today. Today we'll try in two cameras. We are trying to capture entire eclipse sequence in one frame. So there's a tribal man over there. There's a hill. There's a sun shining. It's a telephoto shot. Isn't it amazing? Solar corona from space.
Do we have Sachin
we hope to
online
capture
now?
today. Please be phenomena. So let's welcome Mr. Sachin Bahmba.
Sachin, are you online now? And can you hear us? Vikrant, you want to go ahead and finish the presentation?
Okay. Right. So what is happening in these Bailey's bead? So we know that moon is not a perfect sphere. It has many hills
Please
and mountains.
share the presentation again.
So, yeah, pardon? Okay.
Yeah.
Yeah. Yeah. So we know that moon is not perfect. It has lots of hills and mountains. So what we are seeing, it's a composite image. We are seeing the leftmost images are, let's say, they are before the total solar eclipse begins, and we are watching as it is coming from the valleys of the moon. And as the moon is covering, those areas are getting reduced. So Bailey's bead phenomena is becoming thinner and thinner, and we can also see what we call a solar flare, solar prominences. That orange thing on the top left of my screen. I think you can also see it on prominences of the sun. These are giant, like kind of hydrogen clouds suspended in the atmosphere of the sun. And on the right again we have Bailey's bead. Guys, this is very cool phenomena, and we hope to space hopes to go for many such future expeditions. Total solar eclipses. We hope you too will catch the fever of total solar eclipse. And we'd like to thank you for joining. And in a moment, we will see Sachin sir. Maybe the connection there is not too strong, but we have an alternate arrangement for you. Yes. Over to Mila.
Yeah, so while we're waiting still for Mr. Sachin Bahmba to show the stream, I'm going to just go over because a lot of you, are wanting to see it right away. And right now there should be partials started in some areas. So I'm just going to go over and share a NASA webcast with you till we can get our own. Uh,
हाँ सुनो सुनो, अच्छा मुझे ऐसा लग रहा है कि आपका कैमरा नहीं ऑन है।
Vikrant, please, we can hear you on it.
ठीक है, और आपका जो वेब कैमरा है वो आ रहा है, क्योंकि जब आपका वो विन जॉब ऑन, ठीक है, विन जॉब ऑफ करके आ सकेगा। ओके ठीक है।
Hi, Mayank. Is this Mayank?
Hi, hello, Dipankar.
Yeah.
Welcome, welcome. Mayank is not here, but Mila is, and I think it's over to you.
Yeah, just
Since there is trying to get online.
Okay. Are you able to hear me okay?
Loud
yeah.
and clear.
Okay.
Hello, Dipankar.
Hi, Mila. Yeah, I can hear you very well. So can you hear me all right?
We can hear you fine. And this is
Okay,
Vikrant.
good.
And we're still trying to get Sachin live. And he just has joined. Hi, Sachin.
Hi, Mila. Okay, Dipankar. Hi, Dipankar. I can.
Okay, good. Nice to see you, Sachin, with your nice sunglasses.
Let me show. Yeah, let me show you what is going on. So there is a. This is a 600 focal length on a astro tracker, along with the. This is the one 50 length which is giving you the feed. Are you able to see the feed right now?
No, not yet.
Not yet.
I'll just check. Maybe I'll have to join on the second account to send you the feed. Just check. Okay, then we have. This is the flash spectrum experiment going on. I'm getting a wonderful spectrum right now. So in fact, the sun is also along with the spectrum in the same field. Now this is 10 taking a very wide field of view. 400 100 and again a wide field of view. So let me also introduce you to the members.
Hi.
Kanu.
Hi, who's this?
Mila and Dipankar.
Hi, Mila. Hi, Dipankar.
Hi.
Hello.
Okay, love. Okay, this is love taking photographs. And now you can see we were the first people to park at this place. Obviously, we found a good elevation and we thought this is the place we'll go around. And you can see how many people are here right now. So these are people from, okay, few scientists, my few scientist friends from India.
Hello.
Hi there.
Okay, so this is what is going on, and you can see we are just on the road, and this is all because of us. Those kind of small mela has started here. So I told few experiments to kids. They are trying out their experiments, and let me go and log in other accounts so that you can also see what is happening here. Just a sec. मतलब ये लेगा क्या करूँ उसको क्या करना है डिस्कनेक्ट करना है क्या ऑनलाइन ही रहेंगे हम
I think you're right. I think it's overloaded. I think it's overloaded.
I'm trying it again. Just sec.
Schatten soll chillen und gemütlich. Wahrscheinlich fliegt es so wie die Concorde.
So we would have started partial eclipse in some places right now. So the bunker, while Sachin is setting up, could you tell us what we expect to see at the when the total eclipse starts at contact point 2? Once I just have to unmute you.
Yeah, I did
Yeah.
that. Yeah. Okay. So the initial phase of the totality, you are expected to see the chromosphere, which is the first few thousand kilometers of the solar atmosphere, and sometimes depending on the location of the valleys in the moon, you will see a beautiful diamond ring exactly at the second contact, and you will start seeing the totality afterwards. So during the totality, after a few seconds, you will start seeing the extended part of the solar atmosphere. That's called the corona. And of course, the solar corona is a variable atmosphere. So the structure of the corona is different at different times. And now this year, there has been some prediction of the solar corona. In fact, one of our colleague from Kolkata, Dipendu Nandi, has just submitted a paper yesterday morning about the shape of the corona which you expect to see, and it's make big news all across India and abroad as well. There are two actually competing sort of theories about the structure of the corona or the prediction of the corona. There is one US team, they have also given their prediction. I see those images, and then the Bindus also. They have a lot of similarities as well, but there are certain subtle differences as well. So it's a really interesting time to verify which is going to be more accurate. So we will see the extended part of the corona, bright emission for 2.5 minutes. Typically, of course, depending on where you are in the totality path. And then again, the same thing gets repeated in the third contact. Again, the location of the valleys will dictate where the diamond rings are expected and so on.
Yeah, thanks, Dipankar. And again, for those, if I haven't introduced you, this is Dr. Dipankar Banerjee. He's with us from Indian Institute of Astrophysics. He's going to talk us through the total eclipse as it happens.
Is this being broadcast live to all of India?
Yes.
So 1 billion people are watching here?
Yes.
Amazing. You guys are great.
Yeah. Somebody just commented 12 million people are watching this. You guys are great. So thanks, Dipankar. Everybody was listening. You were on mic.
All right. Thank you.
So we still have Sachin Bahmba there in Oregon now, trying to get together the stream. We have a lot of students asking questions and waiting to see the eclipse.
Okay, Mila, I'm trying again. Maybe now you should get the photographs. Just a sec. Yes, it is trying. It is trying. I should be there in any moment.
So we're. Dipankar, do you want to talk more about why this eclipse is special and why so many people in the US are excited about it right now?
All right. So as far as total solar eclipse is concerned, being in India, I think we are more fortunate than the people at the West, because it's a very rare event as far as United States is concerned. And also the totality path is going across, on the mainland, often the totality path goes through, to water bodies, and then it is very difficult to observe the totality from, any moving object, say, a boat and so on. So it's a great opportunity for the people in the US, particularly, to see the eclipse from a wide, positions across the country. So that's how it is pretty rare. The other concern is often, the sun. It is a magnetic star, so you have a variable corona, as I mentioned before. So the extent of the corona depends on how active the sun is. So this time sun is reasonably active, and you are expected to see, beautiful structures in the corona. And there are certain helmet-like structures in the corona. They're called helmet streamers. This is predicted that we will see probably at least a couple of good, helmet streamers this time. So it will be a beautiful extended corona, which is expected to be seen.
Now you should be having my first video should be there minute now, any second now.
Okay.
Okay. We are waiting to see. Excited to see the stream.
Oh no, it is an error. Let's see. You're not getting it right now? Oh, it says video call ended again because of the connection was lost. Should I show it to you through this one? Just a sec. I'll try something else so that you at least people can have a look on what's going on here. Just a sec.
Right.
I'll put this camera on the.
But here we can see no problem. Like that.
Okay, so let me show you the first photos. I don't know. Can you see it?
Yeah, we can see a projection.
Just a sec. Just a sec. Let me change the camera. No, this is you can see it on my laptop. So can you see the eclipse sun now?
Yeah, that's
I think
it.
I'll have to do something to make it dark so that you can see the sun. So that's the right now. That's the situation right now. So let me make it
That's
a
a
little bit
partial.
dark. Yeah. Uh, we- love. Can you close this? There's a cable here. It's okay. So that's the situation right now.
Yeah, we see it on your screen. Yeah, but the
Yeah.
background is little bright, and
Yeah, I'll do that
probably,
also.
yeah,
I'll
in
change that.
totality it will be difficult. But anyway, let's see.
Love. ये भी क्लोज कर दे, ये वाला भी। तो इसको कवर कर दे ला करके किसी चीज से, अंदर से कंबल से। नीचे कर रहा हूँ, इसको अंधेरा चाहिए अंदर, इसको बाद में करना, तो पहले तो ढक्कन बंद कर दे। कौन सा? ठीक है, और थोड़ा सा उधर से भी यार, ये ना बंद कर दे। क्यों? बंद करके रखो ना। Can you close this one? Can you close this one? Just close this one too. Yeah. Can you close this? Just close this door, please. Now it's a total dark. I think now it should be good enough. We almost have half eclipse now. So
Yeah.
15 more minutes to half eclipse. Ja, aber jetzt muss ein Interview machen, weißt du? Live für 1 Milliarde Menschen. I'll go out and just center it a little bit, because you know it's a little bit off track. Let me center it.
Okay. Right.
And I'll be back.
Yeah, and I think we have totality in about half an hour.
Yes. डेटा यूज कर रहा है क्या तेरा? हाँ नहीं, ले ले।
So I think I see that a lot of people are not able to access other sites, including NASA. It's all very high traffic. So Sachin, we are counting on you showing
Yeah,
us.
I'll try to do whatever I can. Don't worry.
So, do you like me side of the moon. Both. I like both.
भाई ये पकड़िए जरा, ये खोलना नहीं है मेरे को, बाहर आना है, सेंटर करना है।
तो अभी ऊपर तो कुछ That's why she doesn't like my music. If I go through it all, it plays a lot more.
So the bunker, when it reaches the total eclipse, we should also be able to see the corona.
It's not
Yeah, I think you're still.
Yeah. So once the totality, starts after the second contact, as I mentioned, first few seconds you will see the, first layer of the atmosphere, which is called the chromosphere, and then after a few seconds you will start seeing the extended part of the atmosphere, which is called the corona. So you are expected to see the corona, and the skies are very clear in most of the places in the US, I understand. So we are expecting a good, totality and the coronal view.
Yeah, in fact, Dipankar, something interesting happened. A team of our friends, Sana, was in Nebraska, and the clouds were, it was too cloudy, dark clouds. So he took a flight and came to Oregon. So Oregon and
I
Idaho
see.
has the best. Oregon and Idaho has the best sky right now. In fact, the Xavier is here. Xavier is already in Oregon, and
Okay.
I think
So Francis
Jeff
is,
Edelhoff,
I mean, is he close to you? I mean,
no, we
Francis
are
Xavier?
around, no, we are around 600 miles apart, but he's
All
in
right.
Oregon.
Okay.
We just crossed Idaho and came to Oregon. He's deep towards east.
Okay. Okay.
Yeah. Okay.
Yeah, Sachin, you can center it back.
Yeah. हाँ ठीक है, इसको सेंटर करना। देखिए ये मैं ठीक जगह मूव कर रहा हूँ।
Yeah, for all those who are watching, the partial is a long phase, but it's going to be good when we get to the total eclipse in 20 minutes.
और थोड़ा सा परफेक्ट, नहीं थोड़ा और, परफेक्ट छोड़ दो, यहाँ पर छोड़ो, यहीं पर। It keeps moving, अभी बाहर चला गया। Move it up a little bit. उससे तो better है।
So we have a few questions, Dipankar. Maybe you can take those questions. I see one that says, "Why can't we see it with naked eyes?" So
Yeah. Right. So the sun is a very bright light source. So of course, it's harmful for the naked eyes. So you're not expected to see the sun when it is bright, but during the totality, one can actually see the, with your own eyes, naked eyes as well. I have done it myself with several occasions. So, but it is a bit risky to know when exactly the totality happens. That's why people advise you to wear always these specific glasses, and particularly, this diamond ring, the second contact and the third contact period, there could be very bright light source from the valleys of the moon, I mean, from the gaps, and that is also very fairly harmful. So, but exactly during the totality phase, if it is, say, in this particular period, about 2.5 minutes, one can see the corona through naked eye. There's no problem in that. But one should be careful and guided by, some experts who can guide you and say, this is the total phase. And then you can look at the sun with your naked eye as well. So does this satisfy the question? Sorry, I think Mila, you are muted now.
Yeah, that's right. So yeah, that was good. That was a good answer, and we are back to seeing Sachin's screen, and now it's more than half eclipsed. We are getting towards totality in about 20 minutes, I think. So let's see.
It could be less. Actually, could be even less.
Could be even
I'm
less.
not sure. Yeah.
So we have another question. Why does it happen only once, or why does it happen so rarely? Dipankar, you want to address that?
Yeah. So essentially, totality only happens when moon is between the sun and the earth, and also the beauty is that the sizes, the ratio of the sizes of these three objects are such that it allows you to have the totality, in certain period. So this is dependent on the rotation of the earth and so on. So totality will happen typically, 1.5 years kind of interval from some part of the, position on the earth. But it will not come into the same position again in next year, because the earth is also rotating about a different axis and so on. So the sort of simple answer is that totality can only happen when it is exactly situated in the right position between the sun and earth line, and the ratio of the sizes has to perfectly block the solar disk. The moon's disk has to perfectly block the solar disk, and that can happen only at certain time of several years and so on. I mean, one can probably draw a few figures and then you can explain these things slightly better. But
it's all geometry.
Right.
And what's the main reason of eclipse happening? I guess that's the same kind of answer, but maybe you can explain
It's
that.
just the position of the moon between sun and earth at a specific time of its rotation, which gives you this totality. Because if the moon is not able to block the entire sun, then you will get the partial totality, or sometimes annular and so on. So the totality means that the moon's disk has to perfectly block the sunlight which is coming to certain portions of the sun. So that's why only on a certain portion of the earth you'll be able to see the totality. You can't see the totality from a wide area on the earth's different positions. So for example, this time it is only possible to see some part of the United States.
Yeah, and I think earlier Vikrant showed the path, and it's a narrow path that crosses across the United States west to east.
Right.
So we have another question that why does the corona show at the point of total eclipse?
Okay, it's a very good question. Essentially, the solar emission, which is coming from the solar disk, is primarily very, very bright, which is called the photosphere, that the most of the light comes from the surface of the sun. Sun is like a plasma blob, or it's a spherical ball, and from the surface the light intensity is very, very strong, whereas the emission which comes from the corona is very weak. It's actually 10 to the power minus 6 times. So 1 millionth time brightness is coming from the corona. So obviously, if you have a very strong source, which is the background surface of the sun, and in the foreground you have a very, very weak emission, you can't see the weak emission unless you block the bright emission which is in the background. So here, during the totality only, the moon will perfectly block the solar disk. That means the surface light which is coming from the sun is perfectly blocked by the moon, and then only you can see the atmosphere of the sun. So corona is just the atmosphere of the sun, whose brightness is 1 millionth time the solar disk. Again, I'm repeating that, and that's only possible to see during the totality from Earth.
And you don't really need a telescope to see that, right? We should be able to see it with naked eyes.
Absolutely, absolutely. So it's only the telescope allows you to see a little magnified view. You can just use your telephoto lenses also to just capture the totality. But our eye is very sensitive to wide range of brightnesses. So during the totality, you just can't see it with the naked eye. It's only the sun will appear as a smaller object as compared, because there is still large portion of the sky which is within your field of view. So if you want to see an enlarged portion of the solar corona, then you need a telescope or even a binocular. Sometimes will look nice.
Are the flora affected during the total eclipse?
The flora, yeah. So essentially, the totality happens during the course of the day. In this particular case, it's in the early morning hours and so on. So what happens is different, the birds and animals and the plants and so on, which are all have some life, expects, the sunlight to only be deemed at the evening hours when we have crossed the, length of the day and so on. So it's a very unusual thing to happen that, you have a sunrise, and then within 2 hours again, the sky becomes dark, and then, suddenly there is a visible little temperature drop in the atmosphere and so on, because the radiation from the sun is suddenly reduced, and that creates a sort of confusion in the living, plants or animals and so on. Particularly the birds get confused, because the birds, they tend to go back to their nests in the evening. Suddenly within 2-3 hours, you see that, how come the evening has started so early? So they get confused. So that's the kind of very beautiful thing we often observe during the totality.
And can you also tell us about the chromosphere, how that shows up during the totality?
Okay, so actually chromo means color. So historically, when the ancestors or astronomers have observed the totality, they discovered that during the first few seconds, as I said, the solar disk is perfectly blocked by the moon, and then in the first few seconds you see the first few 100 to 1,000 kilometers of the atmosphere of the sun, which is called the chromosphere. And since beautiful orange colors were seen during these first few seconds of the totality, in the past people have called them as chromosphere, the colored atmosphere of the sun.
Okay, thanks for that. And we are getting closer.
Yep.
I think we have only about 12 minutes or so left. Exciting. So we are all waiting to see how that progresses.
It is the
to see some of the features that Banerjee has been talking about, Corona, and
we are
the
exactly
Bailey
14 minutes
speeds.
totality.
So Sachin, you can describe little bit about the atmosphere around. I'm sure, as I was just explaining, that you tend to have a little drop in temperature, and then suddenly things become little dim, and people get confused that you have just got sunrise few hours back. How come the atmosphere is getting dark? It's like early evening.
Yes. So in fact, we just felt a drop of temperature right now, just right now when you were talking about it. I came inside to tell you about that. So temperature drop is around 3 degrees right now. So
Wow,
we have
that's
not
quite
yet.
substantial. Yeah.
Yes, yes, yes. We are not yet hitting the totality. We have still 14 minutes left. People are, really ecstatic. Everybody is shouting around and everybody is wanting the sun back. So there are few kids here doing some experiment, and people have started running towards us. And they think that this is the best spot because probably few scientists are doing something here. So they think that it's the best spot. So I am seeing more and more cars piling up around, and we are distributing goggles here. Everybody is shouting. Vikrant, can you hold? I'll talk to you later. So everyone is started to shout, and we just clicked few photographs, and our hands were up, and everybody is so excited about this eclipse happening. We are waiting. Actually, there is a wonderful steep hill behind us, so we are waiting for the shadow to come from west, and we all want to observe it. Let's see how things go here. And I'm just going to the equipment again just to center it. Thank you, Dipankar.
Yeah, thanks. Yeah.
And I don't know if you close the door, but it is appearing to get darker.
That's right. That's right. So the background, getting is weaker and weaker. So that makes it more exciting and more beautiful. Suddenly you see a complete change in the, day sky. So that's quite fascinating, actually. And that's why, all the birds and, as I said, the animals get completely confused. What's happening? What's wrong with the sun?
Seem to be getting a lot darker.
Right.
And soon we'll have a countdown. Any more questions? Student who asks, can the solar effect, affect the Earth, like having earthquakes and so on?
No, there's absolutely no problem with total solar eclipse, its effects on Earth, because basically, the sun is radiating its energy all the time, and there are certain minus 0.01% of variation of the solar total emission, which comes from with a cycle of 11 years. So essentially, when the moon is coming between the sun and the Earth, sun doesn't know. So it will not change its radiation by any way. So that really doesn't affect us, in a big way. So there is no, sort of possibility of having a bigger, effect on Earth or its interior and so on and so forth. Since somebody mentioned about, sunquake and all that, I mean, so the earthquake, it doesn't, it is not possible.
Height बराबर हो गई left में ले
Getting pretty close.
बस perfect.
Yeah. He's trying to center it, but we can see that it's getting pretty close. And hopefully do a countdown at that point. We have, I think, Sachin, there your total is at 9 minutes. I think that's my calculation. It's in about 9 minutes.
Oh, awesome. In fact, I wish to go to the other account to log in, but I don't dare it right now because everything is working perfect. I don't want to change the setting. Maybe, you know, if we just have 9 minutes, so I don't want to try it. Maybe I also lose this connection. So let it continue this way.
Yeah, it's fine. Just your, I think the phone's reflection is there. So I don't know the mobile phone's reflection on the screen, which may not be so strong during the totality because the light will probably reduce. Yeah. I mean, once you close the door, probably.
Okay.
Yeah.
But we'll get him back and hopefully on another stream as well. And we can have 2 streams up. So, and you know, the totality is only like 2.5 minutes or less, 2 minutes, some seconds long.
Are you able to see the screen right now? Because I can't see it on my screen. That whether you are
No,
getting my.
we are not able to see.
No, we've also lost it right now.
Just a sec.
I can hear you, but no visuals.
And sometimes people ask why there are eclipses don't occur more often, because the sun, moon, and the earth do come in the same line. And do you just want to address that?
Yeah, so as you said, you know, it is easier to explain it in terms of a little figure or geometrical figure and so on, because the position of this blocked light from the sun, so-called called the umbra and the penumbra, that size is very small. So depending on where this umbra is on the surface of the earth, the totality will happen there. So so it's only few hundred kilometers across where you can have the shadow, and then as the earth rotates, we see the shadow, the path of the totality across a portion of the earth's surface. So often the earth's of course, when earth has plenty of water bodies, so often the totality falls along some sea and so on. So then you can't see them, I mean, unless you have a special boat and so on arranged for that. So this totality path, or the width of the totality, is only few hundred kilometers. So depending on exactly which time of the year and that position of our sun earth line, it's a 3-body system. It's not a on a blank sheet of paper you will always look at is a 2-dimensional thing, but it's a 3-body system. It's rotating along each other's axis. So this particular umbral width will vary at different times.
Hey guys, I would appreciate it if don't do the
Okay, so now we're really close.
really special moment, okay?
And we do have a bottle in front, and Sachin, is that just to keep it up, right?
Yeah, it's called Jugaad technology. So I'm just closing the door now. So for you to enjoy the totality, it's hardly 5 minutes away, 5 to 7 minutes away. So I'll just close the doors and hope the connection works. Okay.
Right.
And I'm going out. I'm going out to enjoy my totality and shout around. Thank you.
Hopefully we can hear your shout also. Yes, so here from India, this is the best we can see. I think all the other sites are very, there are reports that they are very busy right now. Nobody's able to get to the NASA website right now. So this is our salvation. Okay, so Dipankar, when we're getting to total, so would you be able to talk us through the contact points?
Okay.
And what we expect to see as we get there.
Okay. So I will take you when we will see the second contact and the Bailey's bead and so on. So it's only 5 minutes probably away, as you mentioned.
Yeah, it's only 5 minutes.
So the first few seconds from the second contact, we'll see the first layer of the atmosphere of the sun, which is called the chromosphere, and it is expected to give a very beautiful colored, atmospheric image. And then once a few seconds are passed from second contact, we'll get into the total phase, and during the totality, we are expected to see the corona. And this is the extended part of the atmosphere. And this time around, where Sachin is in US, is expected to last for 2.5 minutes typically. And then the third contact will come. That means again the totality is almost getting complete. And again during the third contact, you can see some bright ring, which is called the diamond ring kind of structure, that is dictated by the again position of the valleys on the moon, and the lights come past there. Is almost getting complete. And again during the third contact, you can see some bright ring, which is called the diamond, that is dictated by the again position of the valleys on the moon, and the lights come past there.
Okay, so Vikrant, we are getting towards close to totality.
Yep.
And Dipankar just described what is happening to happen, and you can also talk us through as the stages happen.
Okay, so we are very close to the totality now. I think people must be excited outside.
Yeah, that's
and as
right.
you can see, the sky is getting darker, and I'm sure the temperature outside is also dropped now. Sachin mentioned about 10 minutes back the temperature already dropped by 3 degrees, and I am sure that this time it would be even more than that. And people get quite confused. As I mentioned, it's just a few hours from the sunrise, and then suddenly the sky becomes darker, and something goes wrong with the sun. Sun is getting eaten up by somebody. It's actually nothing but the moon, between us and the sun, which is blocking the sunlight. So we are very close to the second contact. The second contact will be the time when the moon will perfectly block the solar disk.
Dipankar, we just saw wonderful shadow bands, huge shadow bands running across the field.
Yeah,
Yes.
okay.
And Dipankar, can you just explain?
Yeah, you can see the sky is getting darker as he had opened. So the sky would be getting darker, and they were seeing shadow bands. They are like snake-like things going around. So it is just 59 seconds to go. So we are going to watch a diamond ring.
Get up.
So let's hear the audio by the team.
Now the shadow is coming towards us. I can sense it. It's getting darker.
As Dipankar said, like this view is very nice because now it is much darker. Also, the van is closed.
Yeah, we are very, very close to the second contact now.
Okay.
See below.
28 seconds to go.
We'll suddenly see this rim of light also suddenly disappearing, and a bright, chromosphere will be visible.
Okay, 13, 12, 11, 10, 9,
Yeah.
8.
So yeah, the exposure has completely gone crazy now.
Wow,
Yeah.
that's a diamond ring.
Right. That's the diamond ring.
That's the corona and the diamond ring.
But it's slightly overexposed now because the extended part of the emission is coming. It's totality now. It's a beautiful totality they are enjoying. I can see that.
People are shouting.
Yeah.
Right.
It's slightly overexposed, so you see the corona has been too bright. So we are going through the totality now. 2.5 minutes.
About 2 minutes of totality.
Yeah, we are reaching mid-totality in 12 seconds.
We
people are getting crazy out there. I would have
Yeah,
also.
they are going crazy.
Yes, Dipankar sir, you must be remembering your eclipses.
Right, right. This is the only probably last 1 or 2 years I have not been to the expeditions. I participated at least 6 expeditions so far.
Okay, we are grateful that we can witness this eclipse, live. We couldn't be there, but we can watch this live thanks to the
Technology.
team and the technology. So it's 40 seconds of totality to watch another diamond ring. As soon as the totality gets over, there'll be another diamond ring, which will mark the end of totality, and then they will put a filter back, and we will see that thin line on the other side of the sun. Now this time, the sun will be seen on the right-hand side. Put the filter back. So this time, right now, there is no filter covering the sunlight is already blocked by the moons. We don't need a filter.
And that's a planet on top we can see right now, right?
I think it's a cursor.
It's a cursor, yeah, yeah.
Because
Yo!
so that's the diamond ring.
Yeah.
That's the diamond ring. The totality is over, guys. Congratulations.
Yeah.
Hey.
right.
So now they will put the filter back.
Back, yes. And as you mentioned, the diamond ring was on the right top.
Yeah.
To the
So we can
northeast,
see
yeah.
corona. Now the corona is better seen because the camera has adjusted its exposure. On the left, we can see corona clearly. Now there's the filter.
So filters are on back.
Sachin to come back.
Right, right. So how was it, Sachin?
You can see the Venus above it.
That's what I was
No,
saying. We do start seeing
that's
planets right now.
Yeah, yeah, yeah.
Yes. Okay, so now what
Because
is
it's
happening is
darker planets that we cannot see.
yeah, my astro tracker is going to stop tracking anymore. So I'll take 10 minutes off. Okay.
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 Maybe you can wait for a couple of minutes just
yes.
so we get out of this, and then we'll take you can take a break while we ask Dipankar more questions.
So what's going to happen is that we are astro tracker. It's following the sun because as the sun is moving in the sky, there is a tracking system which follows the sun. Now it can track only for 2 hours, and that 2 hours is almost over for the tracker. So the team needs to rewind it and then restart the process to keep the sun centered. So we will have an interruption. So sorry, and we see the sun very nice. Orange filter placed on top of the sun. Camera.
And I think he's starting on the tracking again.
Right here. See if I can get.
But like I said, we do start seeing planets and stars that are hidden by the sun.
Oh boy, look at that. That's right in the pathway. You're seeing now it's getting very dark. Very dark.
So we have 1 hour 18 minutes to the 4th contact that will mark the end of this eclipse. In terms of contact, so I will repeat, the first contact is when the eclipse is set to start. That's when the moon disk apparently touches the sun. It covers it. It's called the second contact. It marks the starting of totality. When that part gets over, that's called the third contact. Moon again touches the sun, just about to leave it. That will be when the moon completely uncovers the sun. So this is some language which is used by eclipse chasers. It makes a lot of sense.
And now, right now, we are just back in the partial phase. And Vikrant, it's going to take another 1 hour.
1 hour, 17 minutes to go.
And by now, we also must have, I read that nobody's able to get to the live webcast, but we must also be getting images on the web.
Wow, there it is, right there. We're at it right now.
And
you can take off your glasses now. You're on the West Coast.
And you know, we do have a colleague who's going to come back pretty soon and get us the best images of that are available right now. Okay, let's. Do you have any more questions?
Many have joined, and we are here till 4th contact. It's difficult to stay, but please stay till the 4th contact. So, because it's always easy to leave once the totality is over, but the real fun is if you can experience all the contacts. Who are live at the site, it will be difficult for them to, you know, stay on and do their photography. So we will be staying with them till the 4th contact is over. So we'd like our support of the viewers. Let's be here till the eclipse is formally over and not just the totality.
Right. And so Dipankar, somebody had a question. What are shadow bands? Because Sachin came and mentioned that he saw shadow bands right before the totality.
Yeah. So essentially, shadow bands are a sort of atmospheric effect in the lower atmosphere of Earth. So suddenly, because of this change in the temperature, you know, with this unusual blocking of the sunlight in the early hours in the morning, and then if you have, you know, as Sachin also mentioned that in the neighborhood, he had a small little sort of hell in the neighborhood. I have not seen that exact location of that. That again creates a, you know, a source for this temperature changes. Sachin is here, so maybe he can explain it a little more. But essentially, it's a atmospheric, Earth's atmospheric temperature thermal effects, and that gets you know, reinforced by different structures in the neighborhood. Sometimes the shadow bands can be due to, you know, some tree kind of irregular structures, which allows different transmissions through different parts of a structure. And then if there is a hill and valleys and in between some structure, that also, you know, allows you to introduce certain temperature thermal changes. It's a repeated pattern of, it's kind of interference pattern which you see in if you just spread a long white sheet of cloth or something, you will be seeing alternate bright and dark you know, layers. These are called bands or shadow bands.
And also, another question is that the totality is going to be at different times across that whole path, right? So
right.
So we
so
just
in principle,
totality.
To ask the question, so typically, as you said, that it will go from west to east. So the people living in the western part of the United States, they are going to see the totality at, say, at one point, say 8:30, for example, you know, and this path will, or this shadow of the moon will go towards the east coast with a certain speed. So the people living in the eastern part of the country will see it after a few minutes from 8:30, this exact totality there. So in principle, actually, there are certain you know, fast-moving aircrafts which chases this path of totality. So it's called the chasing the shadow of the moon. And I understand this time also there are certain, you know, military aircrafts which are devoted for you know, following the track of this shadow of the moon on Earth, and they will have a much longer totality than 2.5 minutes. What you would have been if you would have been in a stationary position on the Earth.
And Sachin, are we back tracking right now? Sachin, we are seeing it, but Sachin is muted right now. So it's going to take about another hour to get to the last contact.
Okay, Mila, can you hear me now?
Yeah, I can hear you fine.
Dipankar, we had 4 planes this time chasing the shadow. You were talking about planes, so I just wanted to give you the
Right,
information. We had 4
right.
of them.
Okay.
So this year, this time there's also a project called Citizen Kate, where they have 70 telescopes of the same telescopes spread from west to east, and there'll be a continuous stream of the same telescopes watching the eclipse, and that's a citizen science project. Many people are participating in that. And Dipankar, do you know of any more interesting projects that are happening or experiments that are happening right now?
Yeah, I must admit,
Since
since, though I have participated in last few total eclipses, one from Easter Island and then prior to that from China and Turkey and so on. But I was completely tied up with several other ISRO projects this time around. I had to stay away from the eclipse chase. Somehow I had to restrict myself. So I've not followed all the experiments, but there are some spectroscopy experiments which the Americans have planned. So there are certain new, temperature lines going to be observed, which they have not been able to observe from US for many years. And most of the totality paths in last few eclipses were from slightly difficult, locations across the. As I said, I was in Easter Island. Only very few could go there and do that experiments there. We did have some spectroscopy experiment as well. So apart from just imaging the corona, there are certain, physical experiments to characterize what is exactly a corona, why the corona emits such an emissions, and so on. There are certain experiments which are planned from US this time.
And as Sachin mentioned, he's also doing a flash spectrum and experiment.
Right. Okay.
And Dipankar, can you explain that a little more to our audience?
So essentially, the flash spectrum is again, taken during immediately after the second contact, and that's essentially to know about what all elements are there in the chromosphere of the sun. So it's like a one snapshot kind of spectrum you take, because the chromosphere is not observed for a very long period of time during totality. It's only immediately after the second contact you see the chromosphere. So you have to take a very fast track spectrum image of the spectrum of the chromosphere, that is historically termed as a flash spectrum. You are taking an image in a flash, and that shows you certain lines in the spectrum which you normally would not see if you take a spectral image of the sun, because you are only seeing the photospheric light in the normal circumstances. Only during the totality you see for the first few seconds about the first few thousand kilometers of the atmosphere of the sun, which is the chromosphere, and that spectrum is called the flash spectrum, which allows us to identify which are the elements there in the chromosphere of the sun, and how, at what ionization state these ions are. So these are some of the physics questions we try to understand, and what is the temperature of the atmosphere and so on.
So, and as Sachin said that there was a visible or a drop that his thermometer could measure, and so it drops that drastically. How much does it usually drop?
So it will again depend on probably the local topography of that place, and like in Indian conditions we see few degrees temperature drop, but I do not know what the temperature drop he has really observed during the the totality phase and the before the first contact. So it appears that in the US, of course, because of again the place where he is, the topography will dictate how much temperature drop you can expect. But a few degrees of temperature drop is very normal. It's very similar to, I mean, if you are in a, you're getting into the, suddenly in the evening, your temperature drops because the emission from the sun is suddenly reduced.
So, Vikrant, do you think it's tracking again, right? We see it coming out of the eclipse now.
Yeah. So it is still 1 hour 6 minutes to go for the fourth contact. And yeah, we see a good, the camera is being tracked fine. That's why the sun is stable in the image. That's very good thing, because a lot of experiments before we could get this stream set up to make sure whether everything will go fine, and thankfully everything has gone fine. So I'm not sure whether the tracker has been rewound yet or not. If not, then they will be rewinding it for sure, because it can't track for complete 2 hours. So there will be some interruption.
So fixing
So
the
there's one
read
question
right now.
Okay. So
Yeah,
what are we
go ahead,
going to
Vikrant.
see from space? Can I ask a question? What are we going to see from space? So that's a question for you, Dipankar sir.
Yeah. So you mean to say during the total eclipse or space in terms of space experiments?
Yeah. During the eclipse, what can we see from space? If we look at, say, from the International Space Station towards the Earth, that's one of the questions we are having.
Okay. Now, right. So the point is, the totality. I mean, anything which is either in the, in space, in the sense Earth's atmosphere and so on, has to be in the path of the totality. So unless you are in the path of the totality, you will not see the corona. We artificially create a corona from space by a device called coronagraph. That's a different ball game. So that we create an artificial total solar eclipse like situation from space, and that allows us to observe the corona 24 hours, 365 days, basically artificially blocking the solar disk. So that's a different scenario.
So
but otherwise, you have to be always in the totality path, whether you are in the ground or in a plane or in a in a satellite. So unless you are in the totality path, you will not see the the corona. And also the problem is, if you are above Earth at surface, I would say 500 kilometers above, you may not be having the right umbra. You have to be in the umbra location to see that. You will not see the totality, but you will see an annular solar eclipse.
So related question we have is, if the ISS is in the path of totality, what will it see?
It will see very similar to what you see from Earth, but it is unlikely that ISS will be exactly on this. As I just was trying to explain, if you just draw the ray diagram of three objects, the umbral, you have to be inside the umbra to see the totality. So if you are above Earth, say few hundred kilometers, then you may not be sitting in the umbra. Umbra may be depending on, again, which time of the totality and so on, you may have a situation where you're not within the umbra, and then you will not see the totality.
And today, of course, there was this path of totality, but there was also a lot of parts in the US that saw partial eclipse.
Right.
So they wouldn't have seen any of these things that we got to see right now, right?
Absolutely. So the partial thing is, the strongest shadow portion is called the umbra, and there are partial shadows in the neighborhood of umbra, which is called in technical terms a penumbra. And if you are in a location on Earth falling in that penumbral region, then you will only see the partial phase. So to see the totality, as you mentioned, you have to go to this dark shadow region, which is called the umbra. And Sachin and his team is thankfully in that darkest shadow region.
Yeah, that's why they traveled to that area. But we have another question. What is a hybrid eclipse?
There could be different combinations of, the annular and, sort of total, that's sometimes called a hybrid eclipse. It's not really the the ideal geometrical configurations of this. You can have different combinations of that, and that's called hybrid.
Vikrant, do you see any more questions that we can bring to him?
I'm checking it.
Yeah, I have to leave in a few minutes.
Right. Yeah, and it's been great having you.
I haven't had my dinner. Sorry. So.
Right. Yeah. I mean,
Okay, Mila, I just have 5 minutes of tracking left, so I'll take you off tracking for around 5 minutes and come back.
Okay.
Okay.
Yeah, that's great.
We have about 100 or odd viewers who have been there with us through the beginning. Initially, there were about 117, and then the number has stayed close to 100 people who have been there. I believe most of us are from India, and many are space students who are joining. So I don't see any new questions coming up. Guys, if you have any questions, please ask in the chat. We will put it forward to Dr. Dipankar Banerjee.
And Dr. Banerjee is going to leave now in a few minutes. So let's just
so if you have any last questions.
And so since we have you here, Dr. Dipankar Banerjee, what about Aditya, and how is that going to help any of this scenario?
Okay, thanks for the question, because this is a very, very important mission from India to have artificial solar eclipse 24 hours, 365 days, because we are going to have one of the payloads on Aditya is called a coronagraph. So that creates a artificial situation from space. At this time, we are going actually quite far to a place called Lagrange at one point. It's several, 27,000 kilometers away from Earth. It's not a low Earth orbit mission. And from there, we will be able to create this artificial eclipse-like situation more comfortably. So we'll block the solar disk by an occulter. It's like you can say, you can just holding a plate in front of your eye on the way to the solar image, and that blocking of the sunlight will allow us to see the corona 24-hour 365 days, and we are expected to launch around 2020, and we are working hard to make this instrument in Bangalore, and we are just working hard in the laboratory to get all these different components of this telescope, and then the testing and all these things will happen in Bangalore in our labs. Eventually, the instrument will be handed over to ISRO, and then it will undergo all these different tests, thermal and vibrations and so on. And eventually, we expect to fly around 2020.
And is that going to show the corona in more detail than we are able to capture during these eclipses?
That's frankly that's true, because you will have possibilities of imaging this object called corona all the time. So you can have different setup of different filters, as Vikrant was mentioning, or different spectral configurations or spectrographs. It allows you to do a lot of experiments. The totality from the Earth is so rare, as you can see, just 2.5 minutes, and it also happens in certain positions on the Earth. You may not have a full-fledged observatory or anything for your regular setup to do this. So totality from Earth is much more challenging and difficult.
Right.
Whereas for space experiments, you can plan and execute things much more systematically. So that's a big advantage to going to space, but it's much more expensive as well. So it's a different kind of approach. But totality is a celestial phenomena which is everybody to see from Earth with your naked eye when the totality happens, and that overall experience is something which is really, really very, very fascinating and very rare. You can't get that feeling unless you have gone through this totality yourself. It's very hard to explain.
Right. So we hope that space will set up a tour next time.
Yeah.
Mila, we are back on tracking, and I would sincerely like to thank Vikrant for all the equipment, training, and planning he has done. So Vikrant, thanks a lot for you from my side to you. Thank you, Vikrant.
Thanks.
Boss. Okay, boss. Thank you.
And,
This was
thanks,
great to
Vikrant.
see all the action and everything going so well. It's really satisfying to see wonderful work in spite of many challenges faced by the team. It wasn't easy. So thank you. It's a great opportunity for me to be supporting in any way I can. And
thank you, Dipankar. Thank you, Dipankar, for adding the cherry on the top of the cake. So
thanks, Sachin. It's very challenging. I know on the ground how difficult it is to set up these experiments, and as you said, the tracking the sun is not an easy game. It's quite a challenge.
Yeah. Thank you. Thanks a lot. So enjoy your rest of the eclipse.
Yes. So Dr. Dipankar, before you leave, there is one more question for you. When is the next total solar eclipse going to be seen in India? Because many people would be very excited now to watch an eclipse live.
Right. Sorry, I mean, I have not done the homework. Just give a Google search, you will get the dates. I'm sorry, I just not in the top of my head. I should have done it probably, but I was just tied up with too many things.
I have an answer for that then.
Right.
So we have an eclipsechasers.in. That's a website for all the eclipse lovers in India. That's a eclipse wing of space. In this today's this expedition wing is actually Eclipse Chasers as name. So all of you who are interested, please log on to eclipsechasers.in, and we'll definitely let you know when are the most exciting eclipses. For example, there are 2 eclipses going to be happening very soon. One is in, I think, in 1919, and then in 2019 and 2020 are going to be annular. One is going to be in southern part of India, and then one is going to be in northern part. So they are definitely going to be something very exciting, but they are annular eclipses. Eclipse may be somewhere as far as 1934, I guess. But then keep watching our space and we will update you. So thank you for the question.
And I just want to add that US has another total solar eclipse in 2024, only in a few years. And it's actually going to intersect perpendicularly through this line, Carbondale, which is one of the locations right now. So that's one of the reasons NASA and others are based in Carbondale, so they can see the same experiments repeated in just a few more years.
Good point. Yeah.
So,
and Dr. Dipankar, thank you very much. It's really wonderful to have you with us. And memories have been refreshed of your meeting with you long back.
Yeah.
So we need to see you more often.
Sure.
Thank you for joining us.
Sure.
Yeah, thank you for joining us.
So much.
It's been great.
Thank you very much. It was my pleasure. Okay. Bye then. Yeah.
Bye. Thank you. And again, to our viewers, that was Dr. Dipankar Banerjee from Indian Institute of Astrophysics. And he very kindly stayed with us through our view of the eclipse and explained everything as it was going on. And now Vikrant, we are waiting for contact 4.
Yeah.
In another
still 52 minutes to go for the 4th contact. So the 4th contact, let me tell everyone that the 4th contact is when the sun and the moon will part ways. That means that will be the end of this solar eclipse from Oregon, but the eclipse will still be on for the eastern part because the moon's shadow, as if you remember we had shown in the beginning, is traveling from west to east. So the moon's shadow would still be on for another couple of minutes or hours for the easternmost states. But the eclipse will be over for us in another 52 minutes, and at that time, the time in 18 minutes past midnight. So all of you who are staying, it's awesome because you have definitely love astronomy. That's why you are here. And please thank your teachers, your Space Club teachers who have got you fascinated. Space Club coordinators, we really like to thank all the Space Club coordinators and the space educators who've got all the students so fascinated and here watching the live webcast. So we are watching some.
Yeah, we have Prabhakaran back, and I don't know if he's been able to get us any of the best images that are floating around the internet right now.
So there are comments by Jyoti Yadav is saying there is school tomorrow. I'm sure Jyoti Yadav is a teacher who is staying back. Ma'am, please keep spreading the love of science to your students. It's really great. It's really great, and we'll encourage you to join us for the next solar eclipse webcast. And we'll update you from eclipsechasers.in. That's the website, eclipsechasers.in. If you don't remember it anymore, space with you. Yeah, Prabhakaran is here.
Yeah. Hello everyone, I'm Prabhakaran, I'm from Chennai. So that was a wonderful experience to watch the eclipse, and the best part was Totality. Was able to watch the Totality from the Sachin sir's laptop, and as well as from other websites as well. And I could able to pull out some best pictures. So I'm going to share my screen, and I will play the images.
So, Prabhu, will you be sharing your desktop?
Yeah, I'm sharing my desktop.
Yeah, and as we can see while he's sharing it, that contact 4 coming up slowly.
Okay, can you all see this picture?
Have you shared your desktop, Prabhu?
Yes, ma'am, I've shared mine.
Because I can only still see you. Yeah, picture from Madras, or it's floating around because it's Madras.
Yeah, it's from Oregon, and this was captured around 4:57. And the next picture is again from Oregon, from Madras, Oregon, and this was captured.
Prabhu, we can't see your screen share. Have you screen shared?
Yeah,
yes.
We can see it now. I'm showing it, I think. Yeah.
This is the partial solar eclipse pictures, and this picture was captured from a NASA aircraft, and the aircraft name is G3. And this is the picture of partial solar eclipse. And the next picture, this is from Salem, Oregon. Again, it's a partial picture. The next is the totality. So this is the solar corona captured from Lincoln City, Oregon. And the next picture is the diamond ring, Salem, Oregon. Yeah, and this is the best picture because if you can see the screen, you can see the moon and as well as the sun. But you can also see few sunspots. But in the right corner, you can see some object which doesn't look like sunspot. Can you guess what it is?
That's a beautiful totality from Oregon.
Can you able to find out what is that object near the edge of the moon? It's International Space Station. So someone from NASA had captured this beautiful picture with the a partially eclipsed sun along with International Space Station transiting in front of it.
Oh, cool.
So this is the best picture
Like
I could able to
all
pull out.
scientists using the special titanium holders, and all the NASA equipment.
And the next picture is again partially eclipsed sun. And the next picture is the totality. We'll be having a lot more pictures in a while. People will start posting all the pictures. We have a lot of pictures in the Twitter, and as well as the internet. So I want Vikrant sir to speak something about the Bailey's bead and diamond ring effect, since we are seeing the picture of it.
Okay, can you hear me? So Bailey's bead start forming around 10 to 15 seconds before totality. So suppose there are, like I would like to know if our viewers have seen the moon through a telescope. If you watch it through a telescope, moon looks all irregular. So there are lots of hills, valleys and hills all around the moon. So if you were to magnify the edge of the moon with a very powerful telescope, it would not be a perfect circle. There would be lots of small hills. The entire moon has covered the sun. Some last line gets filtered through the valleys of the moon, what are called as the Bailey's beads. It's called beads because it's like a necklace. हीरे जवाहरात का जैसे हार होता है, हीरे जवाहरात जड़े होते हैं. So each of these valley creates like a small little diamond, and the circle of the necklace is formed by the thin corona shining around the rest of the sun. So it looks like a necklace, and this looks like, and they change very dramatically. So they change every second as the moon comes over the sun. So phenomena is very dynamic, and the number of beads reduce, and the last bead is sometimes seen as a diamond ring also. So what we are seeing, this diamond ring is very beautiful to watch, and I remember vividly. I'm imagining, when I was eclipse in 1995, there was this beautiful diamond ring. So they say that diamond lasts forever. Now this diamond is very fleeting. That means this diamond ring, like one light shining through, say, last valley of the moon, the deepest valley in the moon, and the corona which is around the moon. So this forms like a ring with a diamond. So this looks very, very beautiful, and it lasts only just a second. Okay,
I should take this responsibility. Yeah, I want to take this opportunity to thank Mila and Mayank and Prabhu for doing this wonderful hangout. I think it was an effort on your part also. Thank you, Mila and Mayank and Prabhu.
Thank you, sir.
Mila, are you online?
Sachin sir, please kindly describe your diamond ring. How was the diamond ring?
Oh yeah, it was wonderful. Too good, man. Actually, since all my equipment was already automated, I could enjoy the eclipse a lot. Other than, taking care that you were getting the photographs correctly on my screen, there was no other work on me. And I enjoyed diamond ring. It was wonderful. In fact, the second diamond ring was even brighter and better than the first one. So probably the valley on the other edge of the moon, on the other limb of the moon, was much better than the first diamond ring that formed. And anyway, since that phenomena is reversed, it is also much more impactful on your mind when you see diamond ring forming from Bailey's beads. It is a less sort of captivating, but when you see the second diamond ring, because it forms first before the Bailey's beads, it is more impactful on you. Yeah, that's it.
So, and how was the
Sachin sir, one more
corona?
question.
Yeah.
Yeah, Corona, I
Yeah.
could see three streaks. Yeah, I could see three streaks
Okay.
as Dipankar was explaining because of the magnetic activity. I could clearly see three streaks coming out from the sun. One was at
Okay.
around 7 o'clock, the other one was at around 8 o'clock, and the third one was at around 2 o'clock. And it was a wonderful Corona, very, 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 sort of not round, irregular Corona, but not very spread out Corona. So that means, a lot of magnetic activity
Okay.
going on sun at this point of time.
That sounds beautiful. And did you see any? Would you like to tell us, our viewers, like how are the planets in the sky? Because
Yeah,
it is
I
so
could,
difficult to catch. Yeah, sir. Over to you. We are listening. Okay, I think Sachin sir
Lost his audio.
Yeah, I think he's still here. I can't make it out.
And Vikrant, are we now backtracking?
So yeah, we are going good. We are going good. Sachin sir has already set the tracker right. Minutes to go. And since it's late in India, people have started to disconnect. However, we would like to say that jayega nahi, 40 minutes more to go. Stay with us. Enjoy this eclipse till the fourth contact.
And I don't know if we have any more pictures
It is challenging
right now.
So we will, once again, I would like to remind our viewers that our photographs will be available on SPACE website, that is www.space-india.org, and also on www.eclipsechasers.in. As soon as the team sends us photograph tomorrow, we will process it and we will post the diamond ring, the images of Corona on our websites. We are keeping our fingers crossed. Some beautiful results are going to be pouring in.
And I actually heard that there is an image of the ISS in front of the eclipse. There is a picture like that making its way around the internet. So that would be fun to see.
Yeah, let me show
tomorrow.
the picture again.
Yeah.
Can you able to see the picture, ma'am? So this is the picture.
Okay, great.
You can see the ISS as a small little dot over there near the edge of the moon, along with the sunspots. So one of the NASA photographer had captured this.
So these are different pictures that are making its way.
Yeah.
It's a good picture of the Corona, and I don't know, none of us yet. As Dipankar mentioned, there were a couple of Corona predictions making its way around. And I don't know how that matches up to what we just saw. Tomorrow we'll get to know that. And although we are watching the Contact 4 coming up right now, but coming up soon. But on NASA Live, there still are eclipses happening as we go towards the East Coast. So if anybody still wants to watch total eclipses happening, then I think it's still happening on some of the NASA websites. Somebody told me that Facebook Live is going well for them. So if you're not able to catch it on the website, please try Facebook Live. Okay, right now we are not getting Sachin's image right now.
Counting.
Okay, so we had a lot of viewers, and right now it's, of course, late night here too. So thanks to viewers. If you're leaving, thanks for joining us and for sharing this experience with us. But three of us are going to wait it out and wait for the last contact. And I hope some of you would stay here with us.
So we are waiting. Some problem with the feed. Maybe some more technical issues. Murphy's law. So hopefully they'll be back soon with us. We are waiting to see the fourth contact now. So as Prabhu had shown a very beautiful photographs, one of which had shown us this International Space Station. Space Station, it is already predicted from where ISS or the International Space Station will transit the sun. So the photographer has to locate himself exactly on that path.
Yeah.
And image the sun using a telescope to it. So that's how you can take one of our space members. I think it was Prabhu only during Prabhu himself. He's here with us. He had taken such a beautiful photograph of happened about 2 weeks back with the International Space Station passing in front of it. It's a very rare photograph. It's very difficult, but yet he did it.
And Prabhu, if you have a chance, you please share that also with the viewers for a minute.
Yeah.
So astronomy requires a lot of patience, as we are all learning. It requires a lot of patience. We need a lot of instruments. We need a lot of rehearsals and skills. So let's see Prabhu's photograph captured 2 weeks back. Prabhu, can you show it to us?
Yes, I'm just pulling it up.
Okay. Just for our viewers, Prabhu is an educator in Chennai. He's teaching our Space Club students. Okay.
So, and again for viewers, we are still waiting for Sachin to come back and show us the view of the partial eclipse as it's ongoing, so we can get to see the final contact. And here we have Prabhu's image that he recently took 2 weeks back of the lunar eclipse that we could see from India, partial lunar eclipse, and the ISS transiting the face of the moon just as the lunar eclipse was happening. It's an amazing photograph. And in fact, as we learned that eclipses do come in pairs, the lunar and solar eclipse come within 2 weeks of each other, as Dr. Padma Yanamandara Fisher told us in the Hangout. And that's because they are already lined up for an eclipse. So when there is a lunar eclipse, then the solar eclipse is also lined up. So is that a video, Prabhu, that we are seeing?
Yes, ma'am. I'm going to play the video. Actually, this video is slowed down a bit because ISS transit in front of the moon pretty fast. It lasts only less than a second. So the time that we captured was around 11:48 p.m. IST, and it crossed in front of the moon in less than a second. Exactly, to be precise, it's around 0.6 seconds. So we have slowed down this video. So 20 frames per second. So now you can see the International Space Station is moving pretty fast, even in that slowdown video. So let me show another video. This is the raw video without slowing down. The duration of the video is only 1 second.
No, we can't see it. So maybe you can help us know when ISS crosses it.
Yeah. So this is the video. It is actually uh, starting from the right hand side.
Oh, okay, we can see it. We can see it. We just saw it.
Yeah, it'll be
Oh,
very quick.
There it goes. We saw it. Beautiful. Beautiful, man.
So usually we can capture the International Space Station in front of Moon and Sun anytime, but you need to be there in the right place to capture it. But capturing the International Space Station transiting the Moon and Sun along with eclipse is something special. So you need to be in the right place in the right time. So people who have captured today's International Space Station transiting the partially eclipsed Sun and as well as the other things, they had wonderful experience, I guess. So we'll be having more pictures tomorrow because ISS had crossed 3 times in that particular location where we have the totality. So we'll be expecting more pictures tomorrow.
Yeah, that's right.
And Prabhu, can you explain how you calculated that ISS is going to cross?
Yeah, definitely. So actually, we made this plan around 1 month ago to capture this, but due to uh, uh, the the International Space Station's orbit, and due to its orbiting speed, it will produce its altitude. Ideally, it will orbit around 400 to 500 kilometers above the Earth's surface. So to match that, they will do some orbital burn. So at that time, when we planned this, it was near to Sriharikota, which is around 60 kilometers from Satish Dhawan Space Center. And by the time we planned to do recon, but it moved a bit off towards the ocean. So then again, we had to find a different location. So it kept on moving to different places. Then when exactly around 2 to 3 days before the event, we got the right place, and then we captured it with a 16-inch Dobsonian telescope, and the focal length of that is around 1800 mm, and we used a mobile camera because the DSLR camera or any other CCD camera, any other camera may not fill the entire field of view because of the too much of focal length. So we need to use a mobile camera and an eyepiece projection. So we just made a telescope adapter ourselves, and then we placed it on the eyepiece and we captured it using a video. Then we just took that video and we uploaded in a software. We then took all the single frames and then we pasted all the frames in front of the moon disk and we processed it. So that was a wonderful experience.
And can you just keep the image open so people can see what we are talking about?
Yeah.
In one image.
Yep. So this image was captured with the frame rate of 120 frames per second, which means per second it will take 120 frames. And since the transit happened less than a second, to be precise 0.6 second, so we could able to get only 60 frames. And in that 60 frames, around 20 frames is in the shaded area where we had the shadow of the earth on the moon, so we couldn't able to pull out those things. And the rest of the frames are the International Space Station. So we segregated all the frames, all those 30 frames, and we placed it on the
And I don't know where if Sachin is able to come back and show us the fourth contact. Otherwise, we may as well close the session.
हाँ सर, आपकी वेट हो रही है, आपका डिस्कनेक्ट हो चुका है. कॉन्टैक्ट तक देखेंगे बॉस, फोर्थ कॉन्टैक्ट तक देखेंगे हम, आपका डिस्कनेक्ट हो चुका है. आ नहीं रहा आपकी कोई. हाँ ठीक है, ओके.
So, Vikrant, are we going to, is Sachin planning to come back on?
Yeah, for some reason there. So I would like to explain that because today, okay, so they are mobile because as you know that there are millions of people coming to the center line. So the hotels, many months back, so our team being adventurous, they've hired an RV. So they are mobile, but for a mobile setup like this, they're relying on phone, internet streaming. And since there are too many people in the area, the internet connection is not too powerful. So, and near the place where they are, it's a remote area. So we've been fortunate enough to the eclipse so far, and they're trying to connect back. So we're sorry for the problems which we are facing, but this is the reason. Because the team is based out of a remote area, but still we are fortunate to see. So we are hoping to have the stream back and watch the fourth contact. So I've just had a word, and they should be back in a few minutes.
Vikrant sir, I have a question. So the next solar eclipse, which is the annular solar eclipse, which will be visible from India, is around 26th of December 2019. So that's the next opportunity for all of us to capture the annular solar eclipse. So what's your plan for that?
So good question, Prabhu. Thank you for the question. It will help everyone. So always tries to be in the shadow of the moon. So Sachin sir is back, and we are beautiful. The sun is, we can see the sun on the screen, and it looks like someone has, it's like an apple with a bite taken out. It's like almost like an apple with a bite taken off. We have 24 minutes to go for C4. So we are grateful to the team for showing us this beautiful eclipse here in India, and we can still watch this eclipse. It's amazing. So coming back to Prabhu's question, what is the plan for the 2019 eclipse, which is going to be happening in December?
And where in India can we see it from? Do you know that?
Yeah, maybe Prabhu can fill us in. It is actually near the southern tip of India. I can't tell you the exact location, but it's passing very close to the southern, I think Kerala, where we had seen. So it's an annular eclipse. The sun will become seen like a annulus means a ring. And so space has been conducting these, so as we have seen some images, space has been conducting solar eclipse expeditions, whether it's whether annular solar eclipse or total solar eclipse, we are always chasing. So during such times when eclipses are happening in India, we typically take expeditions where public can also join us, where we teach photography or just teach about how to view eclipses. That as the time approaches, because still there is some time to go. So as the time approaches, the exact time will be, but we certainly hope, like many people would show a lot of interest in watching these eclipses, because it also helps break myths and superstitions about eclipses. So Prabhu, I hope in part I am able to answer your question, and more will come when the time comes, but we do look forward to many people joining us and gathering, and maybe many schools opening up their venues and using right ways, right methods like safe solar viewing goggles to show this next solar eclipse, which will happen in India, to large, maybe lakhs of people this time. I hope, Prabhu, that answers. or if you have certain scientific experiments planned in mind, you can please talk.
And of course, space, in fact, plans tours around that time. So hopefully we can plan to take an expedition with a lot of students to that location.
So solar eclipses should be seen by using solar viewing goggles. The partial phases should be always be seen by using solar viewing goggles, because the way, if we can take a magnifying lens and we can burn a paper under the heat of the sun, the same way the lens of our eye acts like a magnifying glass and it focuses light on the retina. That can damage the retina. So there are no infrared sensors in our eye. That means when the retina will be heated, no. So there is no pain. So before the damage is done, there will be no warning sign. So that is why it is important not to test or challenge yourself. कि भाई वो eclipse देख रहा है, उसको देखो मैं देख सकता हूँ. Don't try to do that, because before you know it, your eye can get irreversible damage. So these eclipse glasses which we are using, which are there with the team, filter called Thousand Oaks black polymer filter, which blocks about 99.9% light, invisible, infrared and ultraviolet. Visible, but all the other light which can harm us. So these are the glasses which are recommended by us to use, and they can be purchased for any future solar eclipses. During totality, you can remove the glasses because the sun is hidden by the moon. So totality is the time which we should always enjoy with without any glasses. So it, as they say, it should be enjoyed with naked eyes. That's the best way to enjoy totality. And we can see during totality, we can see planets and stars in the sky. And we have 19 minutes to go for C4. And Oregon is paying close attention to their cameras, because their job is still not over. They must be glued to their cameras, watching their screens. And
I don't know if Sachin is available, so we can ask him some questions, but I think he's going in and out because some of the viewers had questions for him.
I think, yeah, I think I see him.
Yeah, I'm available now. I'm available.
Yeah.
And Sachin, can you tell us more about what equipment you used and what you've been trying to do?
Okay, so the webcast that you are seeing is on a 50 mm focal length, which has been attached with a webcam, which does not have its own lens. The primary lens, the viewfinder of a telescope as its primary lens, and that's what you are seeing on your screens right now. Otherwise, I am doing a close photography using a 500 mm focal length, and then we have a 400 mm focal length, also doing zoomed in photographs of sun and its corona and prominences and chromosphere. Then we have focal length, which is doing a little bit wide photography of the eclipse, a rating which is 1000 lines per square inch, and I recorded flash spectrum results. Yes, I'll be analyzing my results later on once this hangout is over. Then I'll be in a position to tell you, did I capture the flash spectrum or not.
Right.
But the spectrum in itself is coming very good. We have two more wide angle cameras which are covering the complete area in the sky, and we would like to have an eclipse sequence from partial to full to an partial phase again. So that's what equipment we are using. Other than that, the software that I'm using is thanks to Xavier Zubier. I am using Eclipse Mastro, Eclipse Orchestrator Mastro on my Mac books. So two cameras are controlled by my Mac. One is a flash spectrum camera, and another one is the 500 mm focal length camera. Then two more cameras are again Eclipse Chasers, Eclipse Orchestrator Mastro, and that's the pretty much equipment that we have right here. Obviously, we are using ND5 filters. ND5, they were more darker than ND5, so we had to readjust all our exposures that we wrote in our scripts. by the God's grace, it was easier. We just could do it in time. I am up since 3 o'clock in the morning, and I had to rechange the scripts when I took exposures this morning. So it was a hell lot of work to do here. As soon as we got sun out at around 7:30, I only had 2 hours to change all the scripts. And Vikrant, that the kind of focal length exposures that we have used 5.6 aperture and 1/20 for partial phase. So it was a pretty dark filter that we had, and was able to do all the work within time. In fact, I was ready just 5 minutes before you wanted me to be online. Before that I couldn't have been available to you. So that's what happened here in this morning.
And Sachin, why did you choose Oregon as your location?
Yeah, we had 2 options. We had a 100-year map with us. Obviously, the first choice was to go to the central line. And this place in Oregon called Lyme, which is on the border of Idaho, was exactly on the central line. We did not find the internet connectivity. And initially, we had a plan to go to Ola in Idaho itself. But when we called Ola, there was only one. It's a small village with wonderful landscape. But when we called someone there, that guy also told us that there is no use coming to this place because there is no connectivity. I couldn't have done the webcast.
Right.
So we chose, we just roamed around and found a good spot near a beautiful river. And we are exactly, right now, our RV is exactly on the main highway. And we are just, few feet away from the highway. And once we camped our RV, everybody thought this was a wonderful stop, and everybody stopped here. And a lot of people saw eclipse from this place right now.
And on a personal note, Sachin, how many eclipses have you seen so far? Total eclipses?
This would be my 7th eclipse. So, and every time eclipse is a unique experience in itself. I wouldn't miss it for anything in the world. So, a lot more eclipses to go.
Yeah.
You lost this eclipse, Bahmba. Okay, we are back.
What, Vikrant? Come again. I couldn't hear your question.
No, we really enjoyed listening to the wonderful narration of the challenges faced, and that you have been up from 3 o'clock. This is really inspiring for us to know that how meticulously we need to prepare for the eclipse. So Mila we are really grateful to your team and each one, Kannu, Love, Surinder, and yourself, and we are eagerly waiting. Know that the first exposures which you've talked have come out good, and we are eagerly waiting to see. And as soon as we have the images in Delhi, and we will process them and put it on the website of Space.
Okay, Vikrant, thank you. Thanks a lot. I have to go back just to adjust my frame. I'll just be back. Maybe 5-10 minutes. I'll be.
Please, yeah.
Okay. And meanwhile, we can see the contact 4 coming up slowly.
The team is taking out time to talk to us in spite of their experiments. So they have taken wonderful flash spectrum. So this has been very flash spectrum. We will post this photograph. So how do we get to know what is a spectrum? So if we have to know what are stars made up of. So if I ask you that what is you made up of, you can always go and touch it, smell it, but taste it also maybe sometimes. But how do you know what is sun made up of? How's made up of? So this information can be obtained by looking at a spectrum. That means just like through a prism, you can break up light from the sun into different colors. There's a device called spectroscope. It uses a diffraction grating. So when the light passes from a diffraction grating, it breaks apart just like in a prism, but it's of better quality in a spectroscope. So by analyzing, we find either dark absorption lines. That means in a spectrum which is showing colors, we will find some lines missing from some places. This happens because when the light passes gases in the star, these gases absorb certain wavelengths which correspond to some color. So we already know by lab experiments on Earth which color is absorbed by which gas. So that's how it helps. So during this eclipse, we saw chromosphere of the sun just before totality and just after the totality ended. So we took a spectrum of it. Now chromosphere of the sun would show some, that means that it will not be a continuous spectrum, but the chromosphere will be glowing in only certain colors, which will tell us what it is made up of. One of the experiments,
So, Vikrant, we just have 10 minutes left to go. Is that right for contact 4?
4 minutes, 52 seconds to go for the fourth contact, and you can see the partial eclipses. The sun is getting thinner and thinner. So this is an eclipse, many people have been waiting for, and today in USA they will be very excited, and tomorrow I think it would be there in the news itself. The sun is getting thinner and thinner.
And these contacts are very well timed because you can actually predict them geometrically.
Yeah. So I remember when I saw the first eclipse I saw when I was a little kid. This was in 1995, and someone was supposed to shout first contact and I was a part of a group. So someone was in our group was supposed to shout out to let us know that the eclipse has begun. Very excited, and I was looking at the sun through a telescope with a proper filter. And incidentally, because I had a higher magnification, then that sun should never be viewed with naked eyes or telescope without using proper filter. This should always be done in proper care and guidance. So when I saw this first contact, it was so amazing that I still remember I had goose pimples just to see that first contact. So this happens. So everyone who will watch this will always remember, whenever the first contact happens, is a reminder that actually the eclipse is going to happen. This is something which can really be experienced. So we can see now the fourth contact is due in 8 minutes 57 seconds. Sun is a little bright. We can't control the brightness because the camera software doesn't have a brightness control, but it still looks beautiful. So 8 minutes 12 seconds to fourth contact. Prabhu is back with us.
Prabhu, are you on mute or?
Yeah. Can you hear me now?
Yeah.
I was there for the whole session.
His camera was off. Yeah.
Right.
So the next eclipse will be visible in the south part of the India, which is southern India. So we people can see from Chennai. We can see, and
We're all going to come there. Don't worry about that.
Yeah. So people from Kerala, Karnataka, and also from Tamil Nadu can watch this partial solar eclipse, which will be happening 26th of December 2019. And we have the next upcoming lunar eclipse, total lunar eclipse, which will be visible from India and which is going to happen on 27th of July 2018. So next year we'll have a total lunar eclipse visible from India. So last few weeks ago we have got partial lunar eclipse, and the next year we are going to have a total lunar eclipse, which is going to be awesome. Speaking about total solar eclipse and lunar eclipse, I want Vikrant sir to clarify. How many eclipses do we have per year? I mean, per calendar year.
I think we maybe just lost Vikrant. Vikrant, are you back?
I'm back.
Yeah.
I'm back,
So
and that's the sun we are seeing.
yeah, I was
It's a
asking.
little overexposed, but it's still awesome.
Yeah, Vikrant sir, I was asking you a question. So how many eclipses do we have per year, including both solar and lunar?
Yeah. So in 1 year, uh, we could have 2. So how we can calculate this is that we have 2 eclipse season, and in each eclipse season we can have 3 eclipses. So at least 6. I would reckon at least 6. But if I remember that there was an eclipse at the beginning, there was an eclipse season. Eclipse season happened almost nearly 6 years, but 6 months apart. So the answer is like close to 6 eclipses, maybe 7, a maximum.
And
But
Vikrant,
I still need to get back to you on this question for an accurate answer.
right. And how much time is there left to go? It looks pretty close to contact 4 right now.
So 37 seconds. So we have. I will just give you this answer as I'm on a website. So it's 4 minutes to go. So in 1935, we had 5 solar and 2 lunar eclipses. And in 2132, we will have 7 eclipses in 1 calendar year. Again, 2 solar and 5 lunar. So my guess was right. It's about 7 eclipses. So we have 4th contact coming up in 3 minutes 30 seconds now.
Okay, guys. So it's just 3 more minutes of the eclipse. I'm signing off now. I have to just pack up some equipment. So the authorities here are asking us to leave as we can. So
Okay.
Okay.
So we
end this. Sad, but thank you for showing the eclipse. That's sad, and thank you for showing us. So it's still 3 minutes to go.
Thank you.
Yeah,
everyone.
but
Thank you.
I
Thanks
guess
a lot.
we'll end right here. So thank you, Sachin, and your team for taking us through this great viewing together.
Thank you, Mila. Thank you. Thank you for this hangout. Thanks a lot. Bye. Bye-bye.
So it's still 2 minutes.
Bye.
And thank you all the viewers. Mila, over to you. So those are the last glimpses.
Right, those are the last minutes of this eclipse. And I think it's the eclipse has made its way to South Carolina right now, so it is going to end. It's completed its whole path, as I can see on the NASA website. So it's gone through the whole path from west to east, pretty much.
Okay, so maybe Sachin sir will try to push the authorities as long as possible, and we can perhaps see the last contact in 1 minute 53 seconds. One minute 39 seconds to go. We can still make out that the sun is eclipsed. Little bit, there's small dent on the sun on the left. At the bottom of the screen, at the left-hand side of the sun, we can still see, for anyone who may be joining this late. So the sun is still eclipsed. This can be made out by looking, if you look at the bottom of the screen on the left-hand side of the image, there is a small dent on the curve of the sun. That's the moon. And technically now it's 1 minute to go. So we will all do a countdown. I will start the countdown at 20 seconds, and Mila and both of us, Prabhu, you can switch on your camera and let's do a countdown. Be ready for a countdown. 35.
34.
So
33.
So Prabhu, we are going to do a countdown. Let's see if our voices can stay in sync. Say 20, 19, 18,
17.
Try. Let's see.
16.
Okay.
15.
Yeah.
14. 13.
14,
12.
13, 12.
11.
Okay, I will say 3, 1. That's the end of the eclipse. Thank you, everyone. Let's give a clap.
Thanks, viewers, for watching this with us, and thank you, Vikrant, for working out the way to get it and staying with us here, explaining it. Thanks, Prabhu, for being with us and
it's my pleasure.
Talking us through it. And thank you all our viewers for watching this great eclipse with us here today. And we'll meet again next time to watch another eclipse together. And meanwhile, Space will be doing other hangouts that you can watch with us. Thank you, and good night, everybody watching from India. Good night.
Good night, everyone.